Alright, so in this video we're going to talk about circuits and resistors. Okay, remember that circuits can be in series and parallel. And we'll also talk about resistors or resistance in this circuits. Okay, alright, so let's get started. So circuit diagrams. We know that if we have a battery that's connected to a resistor, in this case a light bulb, uh, we can actually make a circuit diagram out of that to represent what every part of that diagram. So you can see that the big line, that lines I put on there, okay, these lines right here, they have to do with the battery. The long one on top is the positive, the small one is the negative. Okay, and then we can add the wires and then the resistors. So you see how we have negative and positive, and then we have the resistor, which is actually the light bulb. Okay, so then that's represented with a big R, and the voltage or the battery, the terminal voltage, which is the battery, we use the delta V, and that would be our total voltage, and I to represent the current, which goes from positive to negative. Okay, we already talked about that. And again, for now, we'll assume that all the wires, and for all your questions, unless they're specifying in the question, the wire has zero resistance. Okay, all right, and then we can also add a switch to this, which you can see here. There's a break in the circuit, so once it's open, there's no current going through there. Okay, so that's an open circuit. And you can also have a closed circuit once you close the switch. Okay, and then we can also say that the open circuit has no current flow and the closed circuit has current flow. Now, circuits or resistors can be two different ways. Okay, they can be arranged in something called series. Okay, so two resistors in series, what it is just it's two resistors where the current has to go through it. Okay, it has no option. So if we're looking at this circuit, the current starts from the battery and it has to go through resistor 1 and resistor 2 and then come back to the battery. Okay, so if the current has no option of going anywhere, then you know we're talking about resistors in series. Okay, and we know that the current always goes from positive to negative, so it would be going that way. Okay, so the I, we know it's current, the I is current, the R is equals resistors or represent resistors, and the V is the voltage. Okay, and in series, something that you need to remember is that the current that goes from that comes out of the battery through the resistor, okay, is always going to be the same throughout the resistor or the circuit. Okay, so the current will go through resistor 1, resistor 2, but the current will be the same, and that's where we get that equation that is at the top right of the screen. The total current equals current 1 and current 2, because it has no option of where else. It has no option of where it's going. It has to go through those, and in series circuits, the current is always the same. Okay. So if we're looking at a battery that's 12 volt battery, you can see that it's positive on the top, negative on the bottom. And the reason it's positive 12, 0 on the bottom is because it's like going up a roller coaster. Okay, you have to go up, and if you go up 12, okay, then you gotta come back 12 as well to get back to the ground, and then you can go back up again. Okay, you can't go up 12 and then come back 14, or only come back 10 and you're at the ground. That doesn't happen. Okay, so if you have positive 12, by the time that current comes back or the circuit is finished, you gotta have 0 volts as well. And that's why at this point right here you have 0 volts, and at the next point where the arrow is pointing, that would be 0 volts as well. And this corner right here, since there's no resistors, okay, yet, see, the current hasn't hit any resistors, the volts will be 12 volts. And then in between those resistors, well, that would be different because it hits a resistor. So you have to use a voltmeter like the ones we use in class to measure the volts, okay? And if you know the resistance, and you know the current, then you can also do it using math. And we know that the volts, because of what we learn about Ohm's law, voltage equals current times resistance. So in this case, we would use the first current times the resistance of resistor 1, and it would give us the voltage. Okay, and from that we can come up with this right here. Okay, in a series circuit or resistors in series, okay, the voltage of the circuit equals voltage 1 plus voltage 2. It's not like current, where current is the same throughout the circuit, okay? And we can also figure out the resistance or the equivalent resistance. What that means is the total resistance of the circuit, okay? And in a series a circuit that has resistors in series, the equivalent resistance is easy to find. All you got to do is add all the resistance together, and that gives you the equivalent resistance. So that's resistors in series, okay? Don't forget that. Now, an example that we have here is two resistors in a series. They give you the resistor numbers, and they're asking us to find the equivalent resistance and the voltage at each resistor. Okay, the voltage of the terminal voltage of the battery is 9-volt battery. Again, you can pause these videos, make sure you get the math right. But first, we need to make a drawing. We can make a drawing that represents the resistors. The resistors are in series. We know that. The current is going to be the same throughout the circuit because it's in series. The resistors are in series. We know the terminal voltage. So the first thing we need to do is find the equivalent resistance, which is just the addition of all the resistors that are there. And if you do that, you get 11.28 ohms. Okay. After that, we need to find the voltage. But in order to find the voltage, we need the current, because remember that voltage equals IR. So in order to find the current, we manipulate the equation. We get the voltage, the total voltage, over the equivalent resistance because of this little triangle here, or Ohm's law. And if we plug in the numbers, then that gives us our total resistance, which equals all the other resistance throughout the circuit because it's in series. So now we can find the voltage drop at every resistor. Okay, the voltage drop in 1 is just the current at 1 times the resistor 1. That's 5.7 volts. And then if we do this, we'll do the same thing in the other resistor. And when we do that, then we get 3.22 volts. And if you want to check, you can always use your equation. Remember that in series, the total voltage equals voltage 1 plus voltage 2. So if you do that, you should get 9.00 volts, or our terminal voltage. Okay, that's an example of resistors in series. Resistors in parallel are a little different, okay, because we gotta manipulate them before we can get the equivalent resistance if it's a complex circuit. But if not, we just gotta do it a little different. We gotta do it's not just, you don't just add them like we did with series. Okay, so these two are two resistors in parallel, 12-volt battery again, 0 volts on the negative side, 12 volts on the positive side, and we know that where the arrow is pointing, that would have to be 0 volts. Over here, 0 volts as well, because if we go up 12, we got to come down 12. Okay, that corner would be 12 volts if you check the voltage with a voltmeter, and on this corner is the same thing, 12 volts, because there is no resistors before we get there, right? Now the current is different. Does the current have to go through R1 or R2? Well, it could all go through R1, or it could go all through R2, or it can go half and half, or 1/3 to R1, 2/3 through R2. So it's going to be different, right? So the total current is going to equal current 1 plus current 2, and that's in parallel circuits, okay, where the resistors are in parallel. The voltage is, that would be easy, because the voltage in parallel circuits is the same throughout the entire circuit, okay? So this just going to switch from series and parallel. Now the equivalent resistance is a little different, because the equivalent resistance, to get the equivalent resistance of a parallel circuit, we would actually have to use the reciprocal of the resistance. So it would be 1 over the resistance 1 plus 1 over resistance 2 to the negative 1. Okay, so you plug in that into your calculator, and that gives you your total resistance. All right. Now to compare these two, okay, you can see that if you give in two diagrams and they're asking you to figure out which one is in series, which one is in parallel, well, the question that you have to ask yourself is, does the current have an option of where to go? Well, on one, it doesn't. It has to go through 1. It has to go through 2. In circuit 2, it does have an option. Okay, it could go all through R1, all through R2, or it can split in half, or it can split into both. Okay. So if there is no option, you know it's a series. If there is an option, then you know it's going to be parallel. Okay, so again, those arrows represent the way the current can go. So let's summarize this, and then I'll do some example problems in another video. Okay, so we know that we have a series and we have a parallel. If it's a series, the voltage equals voltage 1 plus voltage 2. So you add up all the voltages and it gives you the total voltage on a series circuit. The current in a series circuit is the same throughout the circuit, and the resistance is very easy. The equivalent resistance is very easy to uh, find, because all you got to do is add all the resistance. Okay. Parallel is a little different, just because, or voltage and current just switch. Okay, voltage is the same throughout the circuit. Current, you have to add each individual current, and the resistance, what you got to do, 1 over resistance 1 plus 1 over the resistance 2, and you put all of that to the negative 1. Okay, and that gives you your total resistance. Okay, so total resistance, okay, increases if the resistors are in series. So remember that if you have a circuit and you put all your resistors in a series, your resistance will automatically increase. And if you want to decrease the resistance on that circuit, then you put those resistors in parallel. So if these two circuits had the same identical resistors, okay, and you wanted to know which one would provide more power, well, it would be the one in parallel, right? Because uh, power is proportional to current, and we know that resistance and current are inversely proportional. So if resistance goes up, current goes down. If resistance goes down, current goes up. So in parallel, the resistance goes down, so that means current goes up, so power must go up as well.